Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are moving to the next topic of the Unit C, which is the grade 11 chemistry. We're doing the molar concentration today. This is very important for the grade 12 chemistry and the later on chemistry 2. And we do the molar concentration, and this is very important topic. So we use this formula again and again in every lesson after that. So be like very particular without this lesson. So concentration. So concentration denoted by the small c is the ratio that compares the quantity of the solute to the quantity of the solution. It's basically the ratio of the quantity of the solute divided by the quantity of the solution. Basically, if you're writing there as a amount concentration, so you're writing it like this, N upon V. So molar concentration we denote by the big M is the SI unit, and the amount concentration you can write it as the gram per mole is the chemical amount for the solute dissolved in 1 liter of the solution. So this N denotes the chemical amount, which is moles, and number of moles you can say, and the volume is the in liters always, and the C is the molar concentration mole per liter, or you can say the big M. So that's the formula you have to know in this, and we straight to the questions or the examples we have to discuss in this. So the first example says a stoichiometry calculation produces the 0.1 mole of sodium hydroxide in 0.250 liter of solution. Calculate the amount concentration of the sodium hydroxide. You have to find the C, you have N, and you have a V. This is a direct question. So the concentration C is equal to N upon V. N is given to you 0.186 mole divided by 0.250 liters. When you solve this, you get about 0.744 moles per liter. Or you can write it as 0.744 big M. So also note the concentration as a unit. So that's the answer, and this is a simple kind of question, but you can't get this type of simple. There's something like this type of this. They don't directly give you the things, they give you the indirect some things, and you have to calculate for that. So calculate the amount of the 2.45 gram of NaCl in 400 ml of solution. So again, you have to find the C in this, find the C in this, but they don't direct you to give you the N. You have to find the N first. So they given us the mass. So the mass they after given us the NaCl. So if you know the molar mass of NaCl, so you can do something with this. So firstly, we have a mass which is 2.45 grams. So what is the molar mass of NaCl? So you know that. How can we find this? So Na is the Na has the atomic mass of 2.22.99 plus Cl has the 35.45. So you can see from your data booklet, you can know how you know that how can you find these things. We discuss all things in unit B, second unit of the essays. So you can plus this whole thing and you get the molar mass of about 58.14 gram per mole. Now you know how to find the N. N is equal to the small m divided by the big M. So 2.45 grams divided by the 58.14 gram per mole. Grams cancel out. You get your N of about 0.04214 moles. Now that V is also should be in liters. So 20 liters divided by the 1000, you get 0.4 liters. So you convert this thing to. So C is equal to N upon V, and you have 0.04214 moles, and you have this thing of 0.4 liters. And you can find the C from here, which is 0.105 big M, or you can say the moles per liter, and this is your concentration of this. That's how you can find the concentration, and you have to follow this step if you're given the mass. Find the molar mass and then the N, and then do something. That's what I have to do. Last question we have, last example. So now calculate the mass in 15 liter of 3.0 m of solution. Now we have to add the mass, mass. So they're given us the volume, they're given us the C. So firstly, do the backward thing like we're doing the straight thing in this. We find the N, then we find the concentration. Now we have a concentration, so find the N first, then go backwards. So C is equal to N upon V. You have to find the N in this. So N is equal to C times V. C is 3.0 moles per liter or moles, and you get the 15 liters. So when you find this, you get the N of 45 moles. Now this is the calcium oxide, which is basically the CaO. You can find the molar mass for this. Ca is 4.408, I think. Yeah, and we have to plus this by O, which is 16.00. You get the molar mass of about 56.08 grams per mole. Now N is equal to small mass of this. You have to find this thing. So isolate this thing and N times molar mass. N is 45 mole plus 56.08 grams per mole. Moles and moles cancel out. You get your mass of about 2.5 into 10 raised to power 3 grams. This is so big. You can divide this by 10 raised to power 3 again to make it in kgs. So you get 2.5 kgs. The both answers should be correct, but you can, if you want, so you can like shorter this answer like this. It's just 2.5 kgs. So that's all you have to do, and very easy questions. Like you have to know the one formula, and the previous formula we did for this one we did in this second unit. Very important for molar concentration, and we use these formulas again and again in every lesson later on or in chemistry later. So that's all for this, and these are the examples we have to discuss and the different things they ask about. They can't ask about the simple, they even the N and they even the V and calculate the C. They can't tell you about that thing. They will give you some like this type of thing that we do the last two examples. So that's all for this molar concentration, and let me see where your vibe learns but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in this comment section. See you in the next lesson. Keep creative with EduVibe.